So today's lesson is about solving quadratic equations. This is Algebra Unit 2, Lesson 2. So we're going to talk about 3 of the 5 ways to solve quadratic equations. Now, it's really important that you learn to recognize this format. This is the format for a quadratic, and when we talk quadratics, we're talking about things to a power of 2. These terms here, this A, B, and C, are the key values we're always going to be looking at. So we're going to talk about graphing, which is review. We're going to talk about factoring and the zero product property, and we're going to talk about the square root property in this section. So first of all, graphing. When we are looking at ax squared plus bx plus c equals 0, this constant value is your y-intercept. So you always know where it crosses the y-intercept. A tells you if it opens up or opens down. If you have a positive A, it will open up. If you have a negative A, it is going to open down. So this equation right here is our generic basic equation. Obviously, we have some things that are not written there, so I know it crosses at 0, 0 because this is my y-intercept. And I know that because this is positive, it's going to be an open up. So the easiest way to do these is to just make a t-chart, and if I let x be 1, 1 squared is 1. If I let x be negative 1, negative 1 squared is 1. If I let x be 2, 2 squared is 4. Negative 2, negative 2 squared is also 4. And you will begin to see that symmetry that we know exists in parabolas start to take shape. And we can get a rough sketch of our equation. Now, this example over here has a lot of the same examples, so obviously, since there's nothing out here, we're talking about plus 0, so my y-intercept is 0. I know that it is going to open down, and because I'm multiplying by a negative 3, I know that it is going to get very big very fast. And so if I make my t-chart of my x and my y, if I put 1 in, negative 3 times 1 squared is negative 3. Now remember, this squaring is only on the 1. The 3 is going to stay negative. So at 1, I'm at negative 3. If I put negative 1 in, I have negative 3 times negative 1 squared. Negative 1 squared is positive times negative 3. I still get a negative 3. So I can see my line of symmetry developing. And so if I continue, I should do a couple more. So let's do 2. Let's do 2. If I put 2 in, and I have negative 3 times 2 squared. 2 squared is 4. 4 times 3 is negative 12. So positive 2 gives me negative 12. I can clearly see that this is going to be my line of symmetry, so I can, in effect, cheat. If I have a point that's 2 away from the line of symmetry, I have one 2 away here, and that gives me a nice point to draw my graph from. So let's just stop for a minute and talk about what it is we're doing when we're graphing. This whole unit is going to be about solving. And we're going to investigate different ways to solve these quadratics. What we are after are those 2 points right there. Those 2 points are some x value 0. So we really let y equal 0, and we want to know what x is. That is the solution or the root and what we're after. And so we are after what the x value is at these points where it crosses the x-axis. So when we're doing all of these solving problems, that's what we're going for, is where does it cross the x-axis, because the behavior of the graph changes. Here, it's above the axis, so they're positive y values. Down here, we have all negative y values, and then it switches again to positive y values. That has an implication for our problems. So, factoring and, oh, I skipped a graphing one. Apologize, I'll go back. Here we go. Now, this graphing one looks more complicated initially. My y-intercept is 7, and I know it is an open up. So I'm going to go ahead and make a t-chart. I really need to find where that vertex point is, where it reaches its maximum or its minimum and then starts to go back the other direction. So this 7, this graph kind of tips my scale that my values are probably going to be somewhere to that side. So I'm just going to go ahead and start with 1. So 2 times 1 squared minus 8 times 1 plus 7. So I have 2 minus 8 plus 7. And so I end up with negative 6, 7, I end up with 1. So at 1, I'm at 1. I'm going to go ahead and put 2 in. If I have 2 times 2 squared minus 8 times 2 plus 7, 2 squared is 4, 4 times 2 is 8, 8 minus 16 plus 7. I'm at 15 and negative 1, I have negative 1. So at 2, I'm at negative 1. So then I put 3. I still haven't seen my pattern. I don't know if I'm going to go down more, if I'm going to turn and go back up. So I have to do another value. 3 squared minus 8 times 3 plus 7. 3 squared is 9. 9 times 2 is 18 minus 24 plus 7. And I get positive 1. And now I see that I have a line of symmetry coming right here, which means if I cheat, I have another point right there, and I can draw my parabola in right like that. And I do like to use 5 points because it helps me know how steep my graph is. So let's talk about the zero product property. This is the absolute review that we've been talking about for most of your algebra lives. If I multiply any value by 0, I get 0. And if my answer is 0, somewhere in that problem there is a 0. And so really I can take anything, and if I multiply it times 0, it could be 552 million in there. It could be x squared z squared plus 37 billion minus 3,000. It could be some, whatever crazy thing. It will always equal 0. And that's a powerful concept because that is what allows us to solve. That is why we factor. Because if I can get it down to a multiplication problem like a plus or a times b, then either a has to be 0 or b has to be 0. And that is how we solve. That is how we figure out where it crosses the axis. So here are your steps. Always make sure that you are equal to 0. Then you are going to factor, set each quantity, each factor equal to 0, solve each little mini problem, and you have your answers. Remember, if you have a squared thing, you are going to get potentially 2 answers. If you have a cubed thing, you will get up to 3 answers. So, let's review our factoring. If I have minus plus, that means I have minus minus. The factors of 6 that are going to add together to make 5 are obviously 2 and 3. Zero product property says that x minus 2 equals 0 or x minus 3 equals 0, and those are easy to solve. And so what we now know is that this parabola crosses the x-axis at 2 and at 3. That's how the equation, the algebra, and the graph all work together. Now this problem over here, I need to subtract 4 first. P squared plus P minus 56 equals 0. Here I have a plus minus, so that is one of each. Factors of 56, 3, 4. And how am I going to make positive 1 when I am subtracting? Obviously 8 and 7. Set each quantity equal to 0. Solve each quantity. P could be negative 8 or P could be 7. Now this problem also messed up, so this needs to bounce over here. Make sure you keep it in order. So I have 12k squared minus 24k minus 15 equals 0. I always want it in descending order of my variable. First rule of factoring is I look for greatest common factor. I have one. And so now I'm considering how the factors of 4 and how the factors of 5 will combine. Minus minus is one of each to make negative 8. So I really have outside minus inside, and I start going through my combinations of pairing 1 and 4 with 1 and 5. That one doesn't work. 1 and 5, 4 and 1. That doesn't work. 2 and 1 and 2 and 5. That does work because 2 and 10 do make 8. I need a negative 8, so that means my 10 has to be negative. So if I put a 5 there, it means I need a 2 there, a 2 there, a 1 there. Quick check, I have negative 10k, positive 2k, I'm good to go. Now when I go back to my solving, I don't have to take the 3 into account because it doesn't have a variable. 3 is always just 3. So I have 2k plus 1 equals 0, or 2k minus 5 equals 0. Solve each of these, subtract 1. 2k equals negative 1, divide by 2. K is negative 1/2. Add 5. 2k equals 5, divide by 2. K is 5/2. And this is a great example of why graphing isn't always the best choice, because it is an approximation. If it doesn't hit neatly on a vertice, you are estimating. Algebra, solving like this, you always get exact. Now my last example over here, my x squared happens to be negative. I never factor with a negative, so I'm going to move that to the left. So I have 8x squared plus 13x, add 3 to both sides, plus 5 equals 0. So now I'm looking at the factors of 8 and the factors of 5 that will combine under plus plus to make 13. And so when I look at my combination, pretty sure that that one will work. So if I put my 8 here, I need a 1 here. If I put my 5 here and my 1 there, I have 5x plus 8x makes 13x. So 8x plus 5 equals 0, or x plus 1 equals 0. Subtract 5, 8x equals negative 5, x equals negative 5/8, or x equals negative 1. Tune in to part 2 for the rest of this video.